Hello, my name is Johlize McNeil, and this is my final project for the Big Data Processing using Hadoop class. And today I'm going to be talking about Apache Flume. So Apache Flume is a log streaming service, and when we're using it with Hadoop, it can be used to stream log files into HDFS. So in this graphic here, we see the Flume agent denoted by a square, and outside of it, we have a web server that is sending data to our source, which sends it to the channel, which sends it to the sink, and that points to the HDFS. So let's look at the details. Flume sources. So a Flume source is where the data is received. There are many kinds of Flume sources. In this list, just to point out a few, we have the Avro source, an exec source, a Twitter source, a Kafka source, syslog sources, and many others. An exec source is a simple example that runs a command on startup of the agent and expects data to be continuously produced on standard out. Another common source is a Kafka source, and a Kafka source is an Apache Kafka consumer that reads messages from Kafka topics. A syslog source reads syslog data and generates Flume events. So the Flume source is where we read our data. The next component is a Flume channel. Flume channels receive events from the source and buffer them until the sink consumes them. There are a few different types of Flume channels: a memory channel, the JDBC channel, the Kafka channel, file channel, the spillable memory channel, and the pseudo transaction channel. The Flume memory channel, all events are stored in an in-memory queue of a configurable size. This kind of channel should be used when you're looking for high throughput flows. One of the downsides of a Flume memory channel is that in the event of an agent failure, any staged data is lost with no option to recover it. In a JDBC channel, events are all backed by a persistent database. This type of channel is ideal for flows that need to be recovered in the event of failure. A Kafka channel, all events are stored in a Kafka cluster that will need to be installed and set up separately. A Kafka channel will offer high availability and replication for your flows. Flume sinks. Flume sinks consume events from the Flume channel and deliver them to the destination. They store data into Flume centralized stores or another agent. Here are some types of sinks: the HDFS sink, a Hive sink, a Logger sink, an Avro sink, and many others. So if we look at a couple of them, an HDFS sink will just write the events into HDFS. A Hive sink will write events to a Hive table or partition. Next, let's talk about the Flume configuration file. The Flume configuration file is where you configure your Flume agent and describe the sources, channels, and sinks that it should be using. It tells the agent where to look for data, which is our source, how to send it, our channel, and where to send it, our sink. Now we'll enter a section where we'll discuss how to install and set up Flume, and then look at an example of stepping through this. We'll be using an exec source and an HDFS sink and a memory channel. Let's begin by going through the instructions for how to install Flume. We want to download the Apache Flume bin from the Apache website. You can use this link here to download Flume. Once we download it, we can unzip Flume in the same location that we unzipped all of our other projects in user local Hadoop using this command here. Once we have unzipped Flume, we can add it to our path by adding and exporting the Flume home from in our bash profile and setting it to user local Hadoop Apache Flume version 180-bin, and then adding Flume home/bin to our path variable. We can execute the following commands to create the Flume environment and Flume properties files using the templates. So if we take a look at the Flume configured properties template, we can then copy the Flume environment template to flumeenvironment.sh and copy the Flume configuration properties template to Flume configuration properties. In the Flume environment script, we want to set the Java home. Now we can create our Flume configuration file. This is the file where we configure our Flume agent. This agent is called file agent, and its source is tail. Its channel is channel 2, and it has an HDFS sync because we want to copy the files from where we're setting them to Flume, from our source to Flume. So our source type is exec, and the command is going to be running the tail command on a directory with some data in it. Our source tail channel will be channel 2, and now we're setting our sync type to HDFS, setting it to use our Flume installation. Our file type will be data stream. Our channel again will be channel 2, and we're going to use a memory channel, which, as we spoke of before, is an in-memory channel where there is not the ability to recover after failure, but that won't be needed for this example. Now here's the command we'll run to start the Flume agent. Now let's go ahead and enter our hands-on demo. The hands-on demo. So for our first step, we can download Apache Flume and then install it. So let's go to the web where we can go to the Apache org website and download Apache Flume from this mirror. We're installing version 1.8.0. So this should finish installing within a few seconds. And then we can go to user local Hadoop. And here we can see all the other Hadoop projects that we have. And we can go ahead and unzip our download. It's in our downloads folder. And now we can unzip it. So here we see all of Flume unzipping and installing. And now we want to update our bash profile, so we can go ahead and view the file. So here we see that we don't have our Flume home set. So let's set it here. We can just copy it over. And then we should add Flume to our path. So we set our Flume home to user local Hadoop Apache Flume -1.8.0-bin. Now let's add Flume home to our path. And we want the bin directory here. So if we go ahead and we save this and then we run it, we can go ahead and test that it worked by saying Flume ng. And here we go. We see some of the options and we see that Flume was installed correctly and can be run. So now let's take a look at some of our Flume templates. So let's go into our Flume directory, and then our configuration directory. And in there, we can see our Flume configuration properties template. So we can go ahead and take a look at it. Oops, it's the Flume configuration properties template. And here we can see some of the configurations that are set in this file. So let's go ahead and we can use this as a default. So we're going to copy this over to just be called Flume configuration properties. And we can do the same for the Flume environment template. So let's copy those over. And then in our Flume environment script, we want to set our Java home. So let's go ahead and open that file. And in here, we can see we have our Java home, and we can go ahead and uncomment that and set it to be what ours is in our environment, and it's user lib jvm java. So let's go ahead and save that file. And now let's take a look at our very important flume.conf file. So we can go ahead, if we look in our current directory, we can see we don't have one. So let's go ahead and create one. So here in this file, it's currently empty, and we can go ahead and copy over the Flume configuration file that we went over in our presentation. So here we go. Didn't copy correctly here. So let's add that in. So our file agent is the name of our Flume agent. And we set its source to tail, we set the channel, we set the sync, and then we go ahead and configure that source and that sync and that channel in these sections here. So this is the important, very important Flume configuration file that basically tells Flume what it's looking for, the type of source, channel, and sync that it should be using. And in more complicated Flume files, multiple of these can be set up. So we can go ahead and save it. And now let's go ahead and take a look at our Hadoop file system quickly. So if we go ahead and rerun Hadoop fs-ls/, it'll take a minute to run. And we can look and see that there's no /flume directory in here. So now let's go ahead, and we want to run this Flume configuration command from our Flume installation directory, not within any of the subdirectories. So we can go ahead and copy this. And let's take a look at it here. So we're running the flume ng command with agent, and we're setting our configuration file, flume.conf, and we're setting our logger to debug, and then we're saying that we're running our file agent, which is what we named our Flume agent. So let's go ahead and run that. Okay, so we see that it's running here. And now let's go ahead and run Hadoop fs-ls/ one more time. And here we see we now have a /flume directory. So if we take a look at what was in our flume conf file, we see that we wanted to run the tail command on this user data that we've been using throughout the semester. So let's go ahead and take a look at what's in our flume directory. So in our flume directory, we have a flume data file. So let's go ahead and cat that file. Flume data.1544886827271.tmp. I got the wrong file name, so I'm just going to copy it over to make sure that I get it correct this next time. Hadoop fs-cat, and then let's paste the name of our file. Something seems to be going wrong here. Not sure why it's not. Oh, there we go. I accidentally had a .tmp at the end of it. So if we look here, here's some of our data that we could have expected from that u.data file showing up now in our Hadoop file system just by running this Hadoop command. And as you see here, it runs a tail, so it only has a few of the commands there. But if we were continually to add to this file, there would be more and more entries. So that's what's great about this, is as we update our file, more and more entries can be added into our Hadoop file system without having to copy it over manually. So that was a brief introduction to Apache Flume using Hadoop and setting our sink to be our Hadoop file system. That concludes this presentation, and that concludes this video going over Flume and my final project for the semester. This class has been really great, and I've definitely learned a lot about Hadoop and how easy and simple it is to use many of the other projects associated with it and get your data into Hadoop and then be able to run queries and learn things about the data there. So this has been a very valuable class, and I just want to thank you and have a great rest of your semester. Thanks.